So I want to talk about retrieval augmented generation, which is a very common technique to help overcome some of the limitations that we have when it comes to talking to a large language model. So let's level set over here first. And since we'll be talking about interacting with large language models, let's give it kind of a definition on what a large language model is, because there's a lot of them out there. But the one I normally go by is a machine learning model that aims to predict and generate plausible language. And I highlight predict and generate because those are the things that I normally focus on, right? A large language model is a predictive model. It is trying to guess what's going to happen next. It does it through a series of very complex things. It uses neural networks and things, and it's called large language model because it's trained with a vast amount of data. But it is a predictive technology. So if you imagine if you were to give, for example, this phrase to a large language model, when I hear music, I want to blank. Internally, what a large language model is doing is assessing what the probability of what the next word or words might be that come after that. And it internally might calculate, dance might be 8.9%, sing, play my guitar, cry, and those things. And depending on how you have the settings and certain things, it will choose one of these options as a way to complete it. And once that phrase is completed, let's say, for example, it chose sing as the next one, then it'll take that entire phrase, when I hear music, I want to sing, and then it'll try to predict the next one, and then the next one, and the next one. So in essence, they really are just very complex and very powerful autocomplete systems, if you will, right? If you use, on your phone, the autocomplete function, large language models are just very, very large complex versions of those things. So they are probabilistic systems. They are trying to guess what's going to come next because they're trained with very vast amounts of language. They are geared towards understanding and generating language, and they are again trained with vast amounts of those things. But they don't. I really have to emphasize that they are trying to predict what comes next, and in that pattern, that repeating pattern, that's how they generate new things. As wonderful as they are, they do have limitations. The two main limitations that we often encounter when dealing with large language models is number one, it's limited in knowledge. What this means is that despite the enormous amount of data that is used to train the model, the cutoff on what it quote unquote knows is the cutoff date on when it was trained. So if it was used data until, say, December of 2023, it won't know anything that's happened after that. So any new versions of things or new releases or anything like that, it won't know any of those things. And it especially does not know anything about your company, right? Because most of your company's data was not used in the training model. So it does have they do have limitation on what they know. The other limitation that we encounter often is what's called hallucination. And hallucinations, we can define them as when an LLM generates inaccurate or fabricated information. We denote those as hallucinations. In reality, hallucination is really, I don't consider it as a flaw. It's actually a feature. It really is the creativity of the LLMs, and they can be controlled. That you can have an LLMs be much more creative or less creative. But when you're dealing with your business data, you really don't want it to be creative, right? You need it to be as accurate and as factual as possible. So we encounter these limitations when we're trying to use LLMs, especially in business environment, where we want to make sure that the data that what they generate is grounded on factual information. So a common technique to overcome these limitations and to enable LLM to access and incorporate information from external data sources is retrieval augmented generation. So the definition I'm going to go by, because everybody has their own way of defining it. This is the one I kind of like the most out of the ones that were out there. So retrieval augmented generation is a technique in which retrieved facts from an external source are used to ground a large language model in their generative process. So again, what's really important here is that, we're retrieving information from an outside source, right? So that's the R, right? And that's the retrieval there in the name. And then we're using that information that we consider to be completely truthful, to be facts, to then use that in the generative process of the LLM so that they have actual current, factual information for them to generate that. I like to describe RAG as like an open book approach to answering questions, right? So if you ever taken an open book test, right, you're giving the question And then you go to the book and you open it up and you go and you can read the passage and read everything that you need there. And then you can go ahead and answer the question. And so this is kind of the same thing with RAG. If you go to one of your AI assistants online and you ask a question about your business, it's just going to make stuff up because it doesn't know. It's going to try to appease you and try to make stuff up and just answer the question. It'll make stuff up. But if you gave it information about the subject and train on it, it is capable of extracting the information from that context and then be able to give you the right answer. So there's two phases on RAG. So the way it normally works, and we're going to kind of look at the simplified version and kind of a high level of how RAG works, is you start off with a query or a question, right? Usually from the user. And then that is passed along to a retrieval system. This is where we're going to get contextually relevant information that's around whatever that question or that query is, right? What information do we need in order to answer this question? And so we're going to call that context, right? So all the information needed to answer the question. And so we're going to take that context and the original query, and we send both of those now to the large language model. And with both of those things, not just the question, but also with the context, then the LLM is able to provide a more coherent and more factually grounded answer to that. The retrieval can be done in several different ways. It doesn't matter. Whatever's makes sense for the particular query is okay. And this is not, there's no prescription on how the retrieval works. Or retrieval could be, it could be SQL. It could be just stuffing stuff in there. It could be looking through, let's say, data API, or it doesn't matter. As long as you retrieve, right, the whole thing about this is this technique that you retrieve contextually relevant data, whatever is needed to answer the original query. Now, a common way of doing that, or a common approach to the retrieval process, is to use semantic search. So what you would do is you send the query into an embedding model, and that generates a vector embedding. And then with that, you search through the database using semantic search, and you retrieve the most contextually relevant passages or pieces of information from that database, again, using that original query. And you take all of that information, right? That becomes your context. And then you send that along with the original question to the LLM, and then that produces a grounded answer. So I'll show you a quick example of kind of what that might look like in the FileMaker world. So I've got over here a FileMaker file that has semantic search set up here. And I've got a list of documents here in my found set. I've got 6 documents over here. And I got a question that I'm going to ask. And so what's going to happen, I'm just using semantic search, nothing else. There's no LLM here. And what I'm going to do is let's pretend that I have a question of what the function of a Scrum Master is. And I'm going to ask this question. And so I'm going to click here on search. And what's going to happen is it's going to go through my database. It's going to take that question. It's going to convert it into a vector embedding. And it's going to use the built-in semantic search features in FileMaker, and it found all these pieces of the documents that I have over here. It searched to find the right documents. Not all these documents are about Agile and Scrum and stuff like that, but it found the right ones, or it found the ones that are most relevant to the question that I just asked, right? And put them over here. And so now, as a user, if I want to answer this question, all I have to do is go through these, read these, and I know that the answer is very, very likely in some of these pieces of documents, which is that alone, right, helps me a lot. I don't have to use keywords specifically. I know that the answer for this question is very, very likely among these things. So all I have to do is just read all through these things. And that's great. That alone would help me a lot. Now, what if, instead of me going through all of these and reading them and doing all that work, if I can then bring in a large language model to help me do that last step? So we're going to do that. I'm going to do the exact same search, but this time, those results, those pieces of the document that you saw there, I'm going to pass those along to a large language model to then answer the original question. So I'm going to click here, submit. What's going to happen is behind the scenes, a semantic search is going to be performed. All the pieces of information that were found there that are more relevant to this question are going to be sent over to an LLM along with the question. And then now the LLM is able to answer that question. Not only is it able to answer the question, but out of all the 5 or 6 pieces of data that I sent over, it was able to determine that 3 of them held the information that it needed to answer this particular question. So if I were to say, just ask the LLM this question, it probably would have just made stuff up. Maybe it doesn't know about these things. This is a bad example because I'm pretty sure most LLMs do know what this is, but the technique about this is that this could have been any type of information. And then this answer over here would have been grounded on that piece of information that I sent over. So what you saw here is what's referred normally as or generally as what's called naive RAG. So it is a very simple approach, very direct approach. So you're doing a semantic search, you're doing one semantic search for the original query, finding the most relevant pieces of information and sending those. As you can imagine, like I said, there's no magic formula. And in neither the retrieval process or in the generative process, this is RAG is just a general technique. I'll stop here and I guess open up for discussion.
So, Ronnie, as I listened to you, I think what really stood out for me was I was reminded when I was in high school and university, and we would have open book tests.
Yeah. Yeah.
Right. And it's like the challenge with an open book test is getting to the piece of data that will give you that answer. You've got to be really familiar with the work so that you can find that information very quickly. And so I would often put flags in my textbook
Yeah.
to say, so that I could quickly see where that relevant, and I could quickly turn to that. And so what semantic search does is, we think of the LLM like the genius in the corner that knows nothing about me or my business. The genius in the corner, we say, here's all my data. But there's two problems with that. One, sending all that data to the LLM as a big chunk can get really expensive and really slow and all those pieces. And the other piece is then it had even more chance to kind of get it wrong because it's trying to find the needle in that haystack. And so what semantic search does is it says, here's 5 needles. Let's get rid of the haystack. Here's your 5 needles. Now pick your best one and give that back to me.
Okay. Yep, that's a great way of putting it. That's a really good, that's a very good way of putting it. I like that one. I'm going to steal that one from you, Marcus.
Can you actually briefly take 5-10 minutes to break down how we do that in FileMaker?
I could do something better. I can actually give you a copy of this file as well so you can go through the code and look at it. It's not particularly hard. It's not that long.
Yeah, no, I think that would be good. I think I'll put it up on the FMAI website so people can go download it.
Yeah, would that be useful would that be useful? I'm asking everybody here. Yes, Peter's got thumbs up. Honestly, this whole file just has these scripts, and most of these scripts are just navigation and stuff like that. There's not a lot of work here for the files. It's when you drop in a file, it does break the files up into little pieces. This is what's called chunking, just because the context window for embedding, there's a limit, and some of these files are larger. So I just go through them and break them into smaller pieces and kind of paragraphs and create vector embeddings for each one of those things. But that's
okay. So let me just back you up there because there's a lot of jargon there. So when you give a PDF, you need to change that into a form of knowledge that the LLM can ingest, can make sense of, and those are called vectors. Yeah. But you can't create a vector of a 1 gigabyte file. You need to create vectors of very small pieces of that then allow the LLM to still stitch it all back together, but pull out very little pieces so that it can pull out that needle and say, here it is, right? And so that's called chunking and vectorizing and creating a vector. And the weird thing about vectors is that it's not readable by us. So we have to have a way to kind of store that information. And so that's what you're talking about. That script is you're chunking it. You're taking all the pieces and getting every piece of straw and putting it down there and saying, this is now readable. This bit of straw is now readable by the LLM because I vectorized it. Yeah.
So that's a great way of putting it. So let's say this is one document. When I drag and drop this particular document was a definitive guide to Scrum, which is somewhere around here. What happens is because it's fairly large, it's got over 7,000 words. It's bigger than I can fit in when I'm doing the embedding for it. So I just break it up into pieces. They are normally called chunks. We split it into pieces of text of the same size. And so these paragraphs, right, these splits, right, of the document, I pass them over, I send them over to the insert embedding the script step that were introduced last year into FileMaker. And then the output of that is an embedding. An embedding basically is it's just a vector with a lot of numbers that translates the contextual content, the meaning of this text into a format that a computer can understand. We don't have to go into like the details of what's inside there, but just what you need to know is that whatever is in here, this is what we're going to search for. This kind of contains the underlying meaning of whatever was in this text over here. So a very smart process, right? That embedding model takes this piece of text over here and then creates this machine readable output that contains the underlying meaning of this text. So when I'm performing the semantic search, I'm searching through these vectors because it's the machine is going to be searching through those. It's going to take that original question that I asked, which is in this case, what is the function of Scrum Master? It's going to convert that into an embedding, and then it's going to compare it to all these vector embeddings as well and find the most relevant ones. And so then what happens is then I take the text, right, that is associated with the ones that it found, and I send those to the large language model along with the question. And basically it says, hey, answer this question given these pieces of information. I hope that makes sense. Given this context, right, and only this context, go ahead and answer this question.
Right. And they're really key kind of FileMaker script steps that kind of enable this so that we can bring the tech close to the data rather than having to send the data to the tech, as we talked about, right? So so you talked about the vector embedding. Can we talk about the LLM configuration step as well? Because I think that's key that a lot of people miss when they get started, how much that simplifies this process. I certainly didn't understand it.
Yeah, absolutely. So the main script here for answering questions is this is one script over here. A lot of it's really error capturing and so stuff like that. So this script attempts to answer the question, given the context that it finds first. We'll try to find all the pieces of information first and then send those over there. So if we walk through this, I just, there's some error capturing over here, clear some stuff. So the first thing it does is try to find those pieces of information that might be relevant to the question that was answered. And so basically what I'm doing over here, I'm performing that semantic find, right? Using the question that the user asked. So it's going to take that, it's going to search through there. I'm asking only to return the 5 highest results, so the ones that are closest in meaning to the original question. So wherever those 5 are, I'm going to take all of those. I'm going to gather those over here. That's what we're doing here. I'm gathering the found set. So all of those pieces of information, I put them all together into one variable called context. So all of those, those 5 pieces of those 5 chunks of documents get put into this variable over here, context. And then I take all of those and then I send it over to an LLM. This is what I'm sending to the LLM and say, hey, based only on the context below, right? Based only on this, try to answer this user's question and give some other instructions, right? Always reference whatever we sent over and stuff like that. Just give it some constraints here. It's like, I just want you to answer the question and it has to be based on the context. And then I say, hey, here's the context. And I'm using this as a placeholder. Literally, I'm just using a substitute later to take what we had in that variable, right? Context over here. And then I just use a substitute and put that in there. So at the end, I've got one variable over here, instructions, that has the original prompt, right? That uses the template with the new context that was put in there, along with the question. And then all these other things are just really about the API settings required to send this over to the LLM. So this is me literally calling the LLM here, sending all of that information. So here's the question, here are your instructions, here's the entire context that you're going to base your answer on. And then we save the answer and just do some cleanup over here. But that's really it, right? Let's find all the context that we can. We take 5, take all of those, and then we're going to send it over to the LLM. So if I were to bring up in our case, right, this was all the information that the semantic search found, right? Those are the 5 chunks of documents that it found that were the most relevant to the question. And all this stuff gets sent to the LLM along with the original question and instructions on answering the question only based off of that context. And when you do that, LLMs are really good at following instructions. That's a great thing. I describe LLMs as being the eager intern. They can do amazing things, but they'll do only what you tell them to do, which is good and bad. They do exactly what you tell them to do, but they'll do only what you tell them to do. So if you tell them to just answer the question based off of that, what this does, again, this reduces the hallucinations because it won't come up with things. You tell it only to answer the question based off of the information that you're giving it. It's really good at that. They're really, really good. Does that make sense?
I mean, yes, right? Like that does. I do want to bring some other voices into this context, but I also want to underscore, reiterate that this didn't start to make a whole lot of sense to me until I had a file to get my hands on. So I think your very generous offer of making this available. This is something that I think will make a big difference for people in understanding this. And I think for the attendees here, right, like RAG really is about, LLMs are cool, but now how do I let my users have access to their data and leverage the power of an LLM to do that? And the answer is some kind of a RAG integration where you're able to chunk up the data, find the bits of straw that are actually needles, and send them out and get all the pieces that you need. And so this is really the key piece to that.
Dan was asking that, if you're splitting a document, right, by size and splitting them up, I guess the question is, you run into the risk of splitting maybe a sentence or something like that and losing some of the meaning there. And he was asking if it makes sense to overlap them a bit. And you're absolutely right. You can go down a whole rabbit hole on what the best chunking method is. Trust me, because you can spend a lot of time. But a very, very common technique is to do exactly that, is to overlap. Finding what the size of the overlap, the size of the chunk, is a whole other thing, right? It varies a lot on what your documents are, how your documents are, what gives you the best, what embedding model you're using. Whole rabbit hole down there. But you're absolutely right. That's a really good question, because it comes up a lot. Everything I did here today, I am using OpenAI for this, but everything I did here today can be done locally.
Okay.
Everything can be done locally. Both generating the embeddings can be done locally, and we've actually included that with FileMaker Server. We've got software that allows you to run those locally if you want to. There are other ways of running those embedding models locally there as well. And the LLMs can be run locally as well. And Heidi posted a couple of links here that of commonly used software to do exactly that. So this file, with just changing the URL, right, where you're pointing, can be made to run completely local.
So Peter, I think what we'll do is next meeting we'll focus on how to chat with local models, because I know that is a hugely important thing to our customers, and so really getting that set up. But essentially, you can look at a tool like Olama or LM Studio, and you just make a URL call to your local host and the port, and it will interact with you like it's OpenAI, just a little dumber.
There are some caveats there, Peter, but yes, the short answer is yes.
Speaking kindling.
Yes. I'm out of the ones. Olama is really great. I think the LM Studio is just so easy to install because you can run directly on. You'll run on your machine. Just download, drag and drop, and you're up and running. I love using it, and it's what I use to test models really quickly because there's no command lines or anything like that. I don't have to do anything. It just runs out of the regular application on the Mac. It just looks like a native Mac application. It's really nice. I think it's a good place to start testing around and playing around with local models. Yeah, LM Studio is really great. And for this script, all you would have to do is change the IP address basically. So for this one here, all you would have to do is because LM Studio follows OpenAI's API, all you would have to do is change, instead of here API.openai.com, you would change this to your IP address or just localhost, and you're off to the races for the most part. I mean, you have to change the model. It'll be different, right? Instead of GPT-4o, it'll be something, whatever local model you want to use. So that's about it.
And Ronnie, you can also use local models to vectorize your data, right?
Oh, absolutely. Yep.
And that's important, right? Whatever vectorizes that needs to interpret it. So if you vectorize with OpenAI, then you need to use that same model to
do the search later. Yes, to
it's like translating it to Spanish and then asking an English major, what does this say?
Yeah, cool. All right, I guess I'll stop sharing. There are no other questions? I don't know.
Well, Ronnie, I want to thank you for your time. I want to thank you for representing Claris at this little startup of a users group. I want to thank everybody who came. I hope you got some value in this. This is certainly, I want it to be a safe space to come and learn and to bring all of your noob questions and figure out what we're going to be doing from there. So yeah, let's, keep an eye up. I'm open to feedback, anything that would be helpful. The fmai.app base is in progress, and we'll go there to kind of, I'm gonna post some of these links up there, and some of these demo files so that people can start pulling them down and interacting with them. And it's a central kind of repository for our knowledge. So with that being said, I'm happy to hang out as people have questions, but I think we'll close the official meeting now and say thank you and next month and all that. And if people want to sit and chat, I've certainly got some time.